How and to what extent can artificial intelligence and high-performance computing help in the fight against COVID-19? In the hunt for answers, European scientists are combining algorithms, biochemistry and molecular screenings as part of a research project that's seeking to identify potentially new molecules that could be used for drugs against the coronavirus. Scientists at this laboratory are using massive computational power against the pandemic. They say the enemy they are fighting is unlike any other.
Compared to other viruses that we've worked on, for instance the Zika virus, the coronavirus has a far greater complexity. It's composed of many more proteins that have very different biological roles.
The team are trying to identify molecules that can block the progression of the virus inside the human body. The problem is researchers are having to explore a huge library of around 500 billion molecules. To identify the most promising candidates in the shortest possible time, they've turned to supercomputers. These can process up to 3 million molecules per second.
Computers are essential as we're able to work at the same time with all 25 proteins of the virus, which are involved in the various mechanisms related to infection, replication, and blocking the human immune system. Everything in a simultaneous way.
The search for new molecules against COVID-19 also requires supercomputers to generate and analyze 3D models of the proteins of pandemic pathogens.
Able to identify molecules that could be useful to counteract the coronavirus, both amongst molecules that already exist, through the so-called repurposing process, and by using new libraries of molecules, applying models that we've already optimized.
After identification, promising molecules are shipped to Belgium. Researchers here first infect cells with the SARS-CoV-2 virus. They then add the candidate molecules and study the reaction of the infected cells. This complex research is partially done in a unique automated facility that works under low pressure so biological material cannot escape. The potential of any given molecule can be assessed in 48 hours.
The robotic arms are taking the microtiter plates in which we culture the cells and which we culture the virus, and they're putting these under pipetting machines, and after some time they put, for example, the virus on top of the cells, and then they put them in the incubator at 37 degrees Celsius, where they will stay for a couple of days, and then after a couple of days the robotic arms are taking the plates out of the incubator and they put them in a automated microscope that is reading and checking if some of the compounds are blocking the virus.
Wow. Scientists say they hope their research will eventually contribute to the development of efficient new drugs in the medium term to tackle COVID-19.